Now, today we're going to look at graphing the secant and cosecant functions. Now, to do this, we need to remember back to what our cosecant and our secant functions are reciprocals of and how they relate to the sine and cosine functions. Now, let's remember the secant function is 1 over the cosine function. The cosecant function is 1 over the sine function. Now, before we go any further, let's think about something. Now, we talked about in a previous lesson about not being able to stand on top of a ball. That if we stood on top of a ball, we would fall off. Now, standing on top of the ball is like being on top of a fraction of 0. So if we have a cosine of 0, that's going to make the secant function undefined. Now, just like the secant function, if we have that sine function being 0, it's going to make the cosecant function undefined. Now, that's what we're going to look at, because at those undefined marks, we're going to have asymptotes. Now, so where are those asymptotes going to lie? Well, let's take each one of these functions and look back at the unit circle. So our coordinates, 1, 0, 0, 1, negative 1, 0, 0, negative 1. Now, what are the radiant values going around at those points? Well, that's 0, pi over 2, pi, 3 pi over 2, and then back at 2 pi. So, now, what do the coordinates mean? Well, the coordinates mean that we have the cosine and the sine values at each one of these radiant measures. So the cosine, the sine, the cosine, the sine, the cosine, and the sine. So, we just talked about the secant is 1 over cosine. Well, where's that cosine 0? Well, that cosine is 0 up here at pi over 2 and down here at 3 pi over 2. So at pi over 2 and at 3 pi over 2, we're going to have asymptotes. Now, so what's going to happen with the cosecant function? Well, let's label out real quick our coordinates here as well. Now, labeling out again our radiant values. Now, remember, our cosine is going to be that second value inside that parentheses. So our sine here is going to be undefined, where we're going to have zeros there. Well, we have a 0 here at 0 at pi and back at 2 pi. So the cosecant, remember, is 1 over sine. Well, we can't have it equal 0 because that would make it undefined. Well, where are those spots at? Those spots are at 0, at pi, and at 2 pi. Well, let's look and see how we're going to graph these functions. Well, we're going to graph them with 3 easy, very simple steps. We're going to, for the secant function, when we want to graph it, we're going to graph a cosine function first. And when we want to graph a cosecant function, we're going to graph a sine function first. Now, our asymptotes are going to be where the functions hit our midline. Then we'll have some points left over. At those points, we're going to make parabolas. And they'll open up either up or they'll open down. So let's begin and look at and see how to graph this y equals secant theta. Well, we need to go through and look and see what our period is. Our period is going to be 2 pi divided by that number in front of theta, which is 1, which is going to give us 2 pi. Then we need to go through and look and see what our amplitude is. That's that number in front of our trig function. This trig function is secant, so our amplitude is 1. Now, what am I going to graph first? I'm going to graph first y equals the cosine theta. Now, doing this, I'm going to go ahead and draw in an xy axis. Label in my period out to 2 pi, so I'll have 0, pi over 2, pi, 3 pi over 2, and 2 pi. I do not have a vertical shift, so my midline is going to stay there on the x-axis. I have an amplitude of 1, so that means I've got to go up 1 and down 1 from that midline. Now I need to graph then the cosine function. Cosine starts up at the top amplitude, midline, bottom amplitude, midline, top amplitude, and now I need to connect my points and make my waves. Now, everywhere that the cosine function hits the midline, I'm going to have a vertical asymptote. Then I take in, and now I'm ready to graph my parabolas. I have 3 points that are left that are not a part of the vertical asymptotes. So now I make my parabolas at each point remaining. Now, one thing that I should do at the very end is erase away this little outline that I made of the cosine function, which just helped me graph the secant function. So the secant function is what we have left here with our parabolas. Now let's look over and look at the cosecant function. Now the cosecant function, we need to label in our amplitude, the number in front of our trig function. That's 1. Our period, which is 1. So it's 2 over 1, which will give me 2 pi, because remember it's 2 pi divided by the 1 in front of theta. Now, let's start graphing in our points that make up our period. Now, these points, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, my midline, I didn't have a vertical shift, so it stays there at the x-axis. I have an amplitude of 1, so I go up 1, and I've got to go down 1. Now, this time, I need to graph y equals the sine theta. So sine starts at our midline, goes top amplitude, midline, bottom amplitude, midline, and I draw in my sine wave. Now again, just like before, wherever my sine meets the midline, I'm going to have vertical asymptotes. Now I take my points remaining, which will be max and min points, and I graph in my parabolas in the opposite direction. Now don't forget, the sine function here was just an outline to help us graph, so we need to erase that away. So all that we have left is our parabolas for our cosecant function. Great job so far. Let's look at 2 others. What happens if we start adding some different changes into the function? So what if I graphed y equals 2 secant 2 theta plus 1. So let's look at this. We have an amplitude change. We have a period change. We have a vertical shift change. Now, because we have these different changes, my first step is to take this function and just turn it into the cosine function. Because remember, I'm going to make my outline here. This outline is going to help me graph the parabolas. So I have an amplitude of 2. I have a period of 2 pi divided by that number in front of theta, which is 2, which is going to give me pi. I have a vertical shift out here, which is going to tell me that my vertical shift line is going to go up 1. So let's start graphing this. I'm going to first start off by graphing my period, 0, pi over 4, pi over 2, 3 pi over 4, and pi. Now my vertical shift line, or my midline, was at the x-axis. But it tells me here that I have to go up 1. So I have to go up to 1, and I've got to take this vertical shift line and drift it up to 1. From that midline now, I've got to go up 2 and down 2 because of my amplitude. So up to 2, up to 3, my top amplitude, down 1, down 2, negative 1 being my bottom amplitude. Now, this function is the cosine function. So it's going to start at the top amplitude, the midline, the bottom amplitude, the midline, and the top amplitude. Connecting in my points, I make my outline function, which is my cosine here. Now, where do my asymptotes go? Well, that's where that cosine function hits the midline. So let me draw those in here. Now, what do we have left? Well, we have left just making our parabolas, going in the opposite direction of our outline of the cosine function. Now, I need to take my eraser and erase away my cosine function. So all I'm left with is the secant function. Let's take one more. Let's take one more so we can look at a different way of graphing the cosecant function if it has an amplitude change, a phase change, and a vertical shift change. Now, our amplitude is 3. Our period is 2 pi divided by the number in front of theta, which is 1, which gives me 2 pi. Now here I'm going to have a phase change as well. We call it phase shift. I take pi and I take the opposite sign of it, and I divide it by the number in front of theta, which is 1, which gives me negative pi. Now I also have a negative 4 on the outside, which tells me I have a vertical shift of down 4. Now, making a graph, and I'm going to need to take that y-axis and slide it over a little bit to graph in my full period here, because I need to start at negative pi, then negative pi over 2, 0, pi over 2, and 2 pi. Now, I have a vertical shift. My vertical shift line was at the origin. It tells me that I got to go down 1, 2, 3, 4, so negative 4. So my midline is going to go down to negative 4. Now, my amplitude says I need to go up 3, down 3, up 1, 2, 3 to negative 1, down 1, 2, 3 to negative 7, and that gives me my top amplitude, my bottom amplitude, and my midline. Graphing in my, if I have cosecant, that's going to go with 1 over sine, so I need to graph my sine. So at my first point of my period, I'm going to be on the midline, then top amplitude, midline, bottom amplitude, midline, connecting in my points. I get my outline to start helping me graph. Now, everywhere that the sine function hits the midline, I draw in my asymptotes. Then I take and make my parabolas. Lastly, I need to erase away my outline of my sine function, and I am finished. Great job with these notes. Go on to your worksheet and go ahead and fill those out.